Hey guys, so point 0.9 repeating means a decimal point and the nines going on forever. This is what it could look like on a screen, but the nines never stop. They just keep going. 99999. If you have point 0.9 repeating, that is equal to 1, and we can put a box around it. Some people think that point 0.9 repeating does not equal 1, and then if we divide both sides by 3, that means they also believe that point 0.3 repeating does not equal 1/3. And I'll put a red stop sign around that. We're going to assume that they're right and explore this for a minute. So they think that point 0.3 repeating is very, very close to 1/3. They think it's just a tiny bit smaller than it. So we can add that tiny bit to it. So if we have 0.3 repeating plus n equals 1/3, they believe this is true. There's something you can add to it. And they believe that it's the smallest thing you can possibly add. I've seen a lot of people call it this before, a 0.0 bar with a 1 at the end. So after all your infinity, you have that little teeny one. So it's the smallest possible number they can imagine. And they also believe that 0.9 repeating is also shy of 1 by that same smallest number. I've even read in my comments people call it the adjacent number, the closest possible number you can get. So let's explore this and solve for n. So I want to rewrite both these equations a slightly different way. That's saying that 1/3 minus 0.3 repeating is equal to n, and that 1 minus 0.9 repeating is equal to n. Basically saying n is the distance between 1/3 and 0.3 repeating, and n is the distance between 1 and 0.9 repeating. Let's throw some parentheses on this top one and then multiply both sides by 3. So 3 times 1/3 is equal to 1. 3 times 0.3 repeating is equal to 0.9 repeating, and then 3 times n is equal to 3n. So now we have two separate equations here. Since 3n and n are both equal to 1 minus 0.9 repeating, we can set them equal to each other. Then we can subtract n from both sides. On the left-hand side, we get 2n, and on the right-hand side, we get 0. Divide both sides by 2, and we get n equals 0. So that means that the number that they defined to be the difference ended up equaling 0. So if we plug in 0 for n, then we can just get rid of it, and notice what we have. 0.3 repeating equals 1/3, and 0.9 repeating equals 1. So by making the assumption that there is the smallest possible number in between them, it leads us to concluding that it has to be 0. And that leads me personally to reject this and accept that 0.9 repeating equals 1. How exciting.